Welcome back. Problem 11.31. So statement is using E is 29 into 10 to the power 6 psi. Determine the strain energy due to bending for steel beam and loading shown. Ignore the effect of shearing stress. So you can see this is beam AD and that is fixed support at point, pin support at point B and a roller support at point C. At point A and D we have a load of 2 kips and the cross section of beam is rectangular, that is height is 3 inch and width is equal to 1.5 inch. The distance from A to B is 1.15 inch, C to D is also 15 inch and from B to C that is 60 inch. So let's start with the solution. Our first step is to find the reaction forces at if we remove the support at point B and at point C. So let this is RB and this is RC. Now you can see this beam due to symmetrical loading, you can see that this RA is RB is equal to RC is equal to 2 kips, and let this 2 kips is equal to P. I will write it P is equal to 2 kips, and let this distance is equal to A. This is A. Also you can apply the equilibrium condition that sum of all movement about point B is equal to 0 and taking the counterclockwise movement as positive, so you will get RC is equal to 2 kips. Clear? And by using another equilibrium condition that sum of all forces along y direction and taking the upward force as positive, so you will get RB is equal to 2 kips. You can do it by yourself, it's very easy. Now we'll move toward our major portion, that we will find the strain energy for different portion AB, BC and CD. So I will move toward over A to B. So if we take A to B and we will cut the beam and draw the free body diagram. So let this is your point A. At point A we have 2 kips and let distance is x, so here there will be a shear force and reaction moment. Let this is 0.1, so we will find the equal moment, sum of all moment about 0.1 is equal to 0 and taking the counterclockwise moment as positive. So about 0.1 the moment is due to this 2 into perpendicular distance is x, and this 2 is equal, we have taken it as P. So I will write it P into X, and that is negative because it is producing counterclockwise, plus external movement which is clockwise, their sum must be equal to 0. So it means that PM is equal to P into X. M is equal to P into X. Okay. So sorry, this moment force into perpendicular distance, and that is producing counterclockwise, so it will be positive. So M is equal to minus P into X. It means that we have taken this moment counterclockwise. The resumed direction is wrong, it should be clockwise. Now we will find the moment equation for portion B to C. So B to C. Now you can see that from B to C this moment will be equal to P into A minus P into A, because you can see at point B X is equal to A, so if you put it, this will be minus P into A. Since there is no loading between B to C, so this moment will be same, so minus P into A. So I will write moment is equal to minus P into A, that is constant. Okay. Also by symmetry, if you look at the figure, you can see that due to symmetrical loading, UAB is equal to UCD because the loadings are same. So I will write UAB AB is equal to UCD, and that is equal to what we have to find, that is equal to integral of 0 to a m square. M is equal to minus p into x, so p square into x square divided by 2ei, and when you solve it you will get it you will get p square a cube over 6 ei. You can do it now. Okay, now for this is for portion AB or CD. Then for portion BC we have this UBC is equal to m square, which is this A into B. Now distance is total, this let this B, 60 is equal to B. So m square B divide by 2ei. So you can put the value, m is minus p, so p square into a square b over 2ei. Now total strain energy U is equal to UAB plus UCD plus UBC. So you can add them. UAB is equal to P square A cube over 6EI plus again P square A cube over 6EI plus P square A square B over 2EI. And if you further simplify it, you can do it. You have to take the LCMs and simple calculations. So you will get, and you have to take the sum common term. So you will get P square A square over 6EI, and we will left with 2A plus 3B. Now this is the total strain energy. Okay, so we have P is given as 2 into 10 raised to the power 3 pounds. A we have taken as 115 inch. And B is equal to 60 inch. Okay, I have power issue. I we will calculate. This is rectangular, so 1 over 12, base is 1.5 and height is 3. So cube, so you will get I is equal to 3.375 inch power 4. So you can simply put it in the above formula. U is equal to P, so 2 into 10 raised to the power 3 whole square into 15 square into 2 into 15 plus 3 into 60 divide by 6 multiply by I is 29 to 10 raised to the power 6 and I is 3.375. So again you will, after calculation, you will get 322 pounds into inch. So this is the answer. So total strain energy for the given loading of the beam shown is 322 pounds into inch. I hope you have enjoyed my video, and if you like, then subscribe my channel and keep watching the videos. Thank you.